This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known. Welcome to the Math Map Book Club. Today is Wednesday, January 14th, 2026. And this is where Kirsty Gilpin and I each week discuss a lesson from the Math Map curriculum that's used in classical conversations. And I'm always just so excited to see how many people are dedicated to knowing God and making Him known through mathematics. And all of you here, thank you for helping us to make that possible. So Kirsty, what do we have today?
Well, today we are looking at lesson 19, open shapes. Share my screen with you all. And I was just thinking, because one of the things, Lee, that we keep talking about is that repetition leads to familiarity, and that when we become familiar with things, we can make connections, but it also can bring us joy, like seeing a familiar face. And so just before we got on, I was listening to The Barber of Seville, which I haven't heard in a while, but it's such a familiar piece that just makes you happy. And so now I have that song, or that, I guess it's not really a song, that prelude in my head. And then, of course, it brings back the memory of Bugs Bunny, and that leads to other things. So for those that are wondering when math is going to be that joyous, I've heard that piece of music many, many, many times, and every time I hear it, it brings me more joy. So I just want to encourage us all to persevere so that our math becomes familiar and brings us joy. And one of the best ways to do that is by using our flashcards in order to build that memoria of the grammar, of the language of mathematics, of the key ideas of mathematics, of some of the common calculations that are going to make math a little bit less burdensome and allow us instead to celebrate the patterns that pop up and over again in mathematics. Again, that idea of them being familiar, bringing us joy because we're seeing them in a new way or seeing something new about them. So this week, we're talking about the benefits of letting your students choose the cards to review the lesson. So whatever lesson you are on this week, we're talking about open shapes. I might ask my students to go through our flashcards and find flashcards that would reflect what they were practicing in the lesson. So that might include some of our calculations. Maybe in your particular domain, your students are adding or multiplying particular numbers in this lesson that you want them to practice. Notations are going to be a common one for all of our lessons, that we can find some notations that are used in that lesson. Again, one of the things that we're going to talk about in our questions and answers is fractions, and how do we deal with fractions and recognizing equivalent fractions. So becoming familiar with those fractions are going to help us there. So again, asking your students to look at your flashcards, whether it's their memoria, going, oh wait, I know there's a flashcard that matches this particular concept, or just taking the card deck and spreading it out and matching it to the lesson, is a great way to help them make those connections and then reinforce that memoria that is going to eventually become familiar to them, so that they start to find the true joy in studying mathematics. Does anybody want to share anything about flashcards?
I just once again share that if your students are struggling, just put the curriculum away and work on the flashcards, and then bring what they're struggling with back out and just have them read that page. Don't expect them to calculate or solve. They really need that foundation.
Okay. So jumping into our lesson, as we look at our covers here for lesson 19, open shapes, we have come back around to our skills of invention. Those are our common topics. And so we've got our definition, comparison, circumstance, relationship, and testimony or authority. Now, usually I try to pick questions that are broad enough you could use them any week, but you'll notice that there's a couple here that are specific to this week. Um, but the first one, definition, is just asking your students to look at the cover and find out if there are words that they can define or if there are words that they need to be defined. So they may feel comfortable understanding what open means. They may be comfortable understanding what shapes mean. But maybe there's something in the quotation or the reflection that is less familiar that you may want to look up. So that's a great way to start by practicing that skill of definition and making sure that your students know what those words on the cover mean. Specific to this lesson, when we think about comparison, is to compare this to lessons 1, 3, and 9, because those are all other covers that start a new dimension. So by looking at saying, okay, so what happened in lessons 1, 3, 9, and 19, you could also look ahead if you wanted to lesson 23 and then lesson 27 and ask them, right, what's different, what's the same, and maybe they'll notice that you see the progression as you line those up. You see the progression of the dimensions up in that top left hand corner. You could also similarly ask them to compare this cover to lesson 18, because in lesson 18 we were still in 2D, and in lesson 19 we're now in 3D. So that comparison is a way to really emphasize the fact that we're now in a new dimension. Also, generated by this particular picture, but may be true for any of our covers, is to ask them if this is the whole picture or is it a portion of a picture. So some of the art that we've chosen, we've zoomed in and just put a portion of the piece of art on the cover because it communicates what we were hoping to communicate for that particular lesson. Some, it's the entire art. Some of our pictures, even if it is the entire art, you could ask your students to think what could be happening outside. Right? So for example, the piece of art that's in Central Park where you have the horses and the people sitting on the bench, if you're familiar with that, you could say, well, what do you think is happening elsewhere in the park? Here we could say, let's look this up and see what else is happening in this picture if this is only a portion of it. Relationship, we know, is often thought of as a cause and effect or an ordering. So you may ask your students, what order did the artist paint this picture? In other words, which pieces of the painting are at the back and which pieces of painting are at the front? So what do you think they did first? Right? How did they layer their paint in order to create this painting? I know that I, as not a very practiced artist, well, I'll put it that way. My children may be less gracious, but as a not practiced artist, I might look at something and try to draw the whole. But one of the things that I learned as a foundations tutor was to not try and do the whole, but to look at pieces, right? To identify the shapes and look at pieces. And so as an artist, if I was looking at this piece of artwork here, I probably would first have started with that purple flower that's at the back. I wouldn't have tried to draw the purple flower with a stem in it, right? I would have drawn the purple flower and then added the stem on top. So there's a great conversation that you can have with your students about the art. And then a testimony authority question that may be more appropriate for your older students than your younger students is to talk about how an author could change the authority of the quotation or reflection. Sometimes we might hear something that sounds really good, and then we find out who said it, and we go, oh, I don't know that I want to listen to that person, right? Or we might hear something and go, oh, I don't know about that. And then we find out that it was in the Bible and that Jesus said it, and we go, oh, well, obviously that was very wise. So knowing the author, right, can change our perception of that quotation or that reflection. And that's a great conversation to have with your older students, especially as they're beginning to do more research and more reading for themselves. How do they know what is a trustworthy source? How do they know what sources are going to give them wisdom? So this is a way to pull them into that conversation. Does anybody have anything they'd like to share about our exordium in general or about this cover in particular?
I would
So
also use this as a time to talk about that word shapes. A tutor or a parent who's been through the curriculum might want to take a moment to say, okay, why do we use the word shapes instead of say objects or figures? Because those are all synonyms that are used throughout the curriculum, and just point that out that we could have said other words, and you may find other words within the curriculum. So that's another comparison question.
mm.
Great.
So I put a picture in the chat today, and this just happened 3 hours ago when we were doing our exordium for math map. And it's the first subject of the day. And we all sat there. We're in booklet 16. It's the circles and triangles. And I was just pointing out the artwork, and all of a sudden in the central Indiana, it started to snow. And all I just started to know that I'm losing the game because it's quite like it's very tempting to go out and say, and so as you can see, it is an empty table. And I took a picture because I thought, well, how can I lift my eyes from the cover art and continue the discussion for 15 skills even when it's snowing? And so when he came in, I asked him, well, how does that snow compare? So to art, what does God's art, which is the snow day, compare to human art? So I'm continue to, I just thought that it's so cool that we can continue to use our circumstance, although this mama is feeling like I have lost the game to the snow, and still continue to try to draw them in, even though I'm not really referring them to the worksheet, even though I don't think I can get them to the 4 pages today. But I thought that's something that I want to share. I said, okay, I think 15 skills are everywhere.
I love that. I wish it would start snowing here. And you would not be the only one struggling to stay on task because snow is beautiful. And I think that showed wisdom, right? To just say, hey, we can talk about God's beauty not only on our cover, but right? We're supposed to be lifting our eyes to his creation and to him. So I think that was beautiful.
That was not my first thought, though. I have to confess. My first thought is, oh goodness, I'm done.
When you were talking about the relationship and how you would have drawn the picture, it made me think about, I feel like in foundations, didn't we have a picture of a flower and we were like drawing it, or we were talking about the parts of the flower or something like that? So I was thinking about, I always like to take my kids back, like, what do you remember from foundations and how does it relate? And so that was something I was thinking about, maybe, asking them about, the parts of the flower, or I don't know, something about that to try to make a connection. But it seems like I remember we had a picture of a flower and we were talking about the different parts, like what do you notice about the flower and that kind of thing. And so it just kind of made me, I was just thinking maybe I could put some flowers on the table as we're talking about this, and just so they could have a image, in front of what the flowers could look like instead of just the painting.
That's really good. That's a good replacement of snowflakes to put flowers on a table.
Right?
It's also a beautiful way to really compare the two-dimensional picture, right, that we're stuck with in a curriculum to a three-dimensional object that we're trying to capture, and having your students really say, okay, what's the difference? What do we lose, right, when we try to capture this in 2 dimensions, especially as we enter into that. And if you really wanted to, you could have some flowers that were still budded and some flowers that were open to really emphasize that difference between closed and open. I like that, Babs. That's a really great way to connect that. After we take a look at our cover, we always like to stop at the math map. itself. And just a reminder that last week we can talk about our dimensions at the end and at the beginning. And so this is a beginning of our third dimension lessons. Notice our 2D lessons. There was a lot of them. That is probably where most of our high school math lives, is in 2D and those 2D lessons. And so now we're entering into our 3D, 4D, and ND lessons. The calculations and the computations have the capacity, right? The context of them has the capacity to become more challenging. There's a lot more things to keep track of, right? If I just have x equals 2 plus 3, right? And in 1D, that's fairly straightforward. When I had y equals x plus 2, it becomes a little bit trickier, right? Now I have to keep track of 2 values. And we see that in 3D, we're going to have 3 values to keep track of. So this page is a great way to talk about those patterns that we can see as we move through the dimensions, and also to notice, right, that we have just 4 lessons in each of these next 3 dimensions, because we're not going to go quite as far, right, as we might do if we were in college or a master's level, right? We could take those ideas and go much farther, but we're introducing these ideas to the student with the goal less that they are masters and experts in the math, and more of the goal that they see how God created order, and they see how God put these patterns into place that we can trust in. And so coming back and always going, okay, yes, we're in 3D. Yes, there's more going on here that we have to keep track of, but what are the things that we probably already know just from the dimensions that we've already been through, right? Just by looking at those images that go along with the dimensions. As we talk about those things, we can ask our students, what are some things that you know about 3D-ness as we enter into this? Does anybody have any questions that they'd like to ask about the dimensions or the math map page? And so that brings us to our lesson page strategies. And so we've talked in the past about customizing the order of the pages. And I think we've probably done a fairly decent job of talking about starting at page 1 and going through page 16, or some subset thereof, or by grouping by the topics. So pages 1, 5, 9, and 13 tend to be similar. 2, 6, 10, and 14, 3, 7, 11, 15, and then 4, 8, 12, and 16. That those groups of 4 tend to be similar. So if I put all of them on one day, my students are not engaging with lots of new ideas that first day, but they're just going a little bit deeper as they walk through. So those are 2 different ways to order the pages. I put up a couple of other orders here because we really want people to feel equipped to use the book the way that best fits their family. Right? And so you could say on day 1, I'm going to look at pages 1 and 5 and 2 and 6. So I'm not going to do just the 1 set. I'm going to do a couple of pages from the 1 set and the 2 set. And then on day 2, look at the 3 set and the 4 set. So I'm still looking at multiple concepts, but not as many. And then on day 3, maybe I try to do 9 through 12, and day 4, 13 through 16. Or perhaps on day 1, right, I want to slow it down a little bit more. Maybe on day 1, I do pages 1 and 2. So again, I'm still looking at a couple of different ideas, but not going with that extra page. Day 2, pages 3 and 4. Day 3, I ask them to try and do 5 through 8 on their own. And then day 4, how much can you get done of the rest of the booklet? So hopefully this just gives you that reminder that you have the freedom to use the booklets the way that best fit you, and not starting at page 1 and going through 16. If we were writing a novel, that would be the right way to read the book. But that's not the book that Lee created. Lee wanted you to feel equipped as parents to use this book the way that best fits your family. Lee, I saw you were going to say something.
Yeah, I just thought of something that our younger families might use as an analogy. So if you go onto Google and do a search and you don't get what you want, you ask it again, or you turn and you do more, you research, just like if you're at a library. And so that's all we're asking you to do on here. So if you've looked at this page that's in front here, three-dimensional space, and you've never actually thought about octants before, put away everything else on that day, kind of flip through it and find out where the octant problems are. Go find the octants in the chart, go find the octants in the I pages, and just learn about octants. It really is there for you to learn what's interesting to you. The ordered learning comes in very much from getting to know the map over the years, as well as doing the flashcards.
Yeah, I think that's a really great reminder that it's okay to just camp on an idea and dive deep. I think about when my children were young, which seems far too long ago. Um, and that would happen, right? With a book, we think it's okay to do that with books, that we're reading The Lion, the Witch, and the Wardrobe with our children, and they decide that they're really fascinated with the idea of a magical wardrobe that would take them places. And they get a cardboard box and they build a wardrobe, and maybe they go and they find a great big coat, right, from a parent's closet, and they start acting it out. And you have this period of time where everything revolves around this story. And we celebrate that. All right. But with mathematics, sometimes we forget that we can do that here too. So Lee, I think that was a really great reminder that when our students' interest is piqued by something, it's okay to camp on that and let them really explore that and not worry about the things that you don't get to, because the beauty of what Lee has created here is that you'll see it again next year. And next year, something else might capture your students' attention. And you might dive deep somewhere else. And so it's not meant for everything to be covered every year, all in one year, but over the course of time to become familiar. So that said, looking at our pages here where we're looking at 3 dimensions, does anybody have any questions from these pages that they'd like to ask?
I do. I would like you to review what seems simple at the bottom of all 3 pages, the notation that's different between coordinates, elements, and sets.
Sure. So as we look here, and I love the fact that this is on all of our sets. So this is a great family conversation to have. And to notice when we look at our coordinates, we have 3. So I would start there with my students, right? And I'd say, okay, what do you think we mean by coordinates? What does this look like? And my youngest students may not remember, but my older students might say, well, we've just spent several weeks writing XY when I want to write a point, right? So I think the coordinates are have something to do with a point. But now there's a Z, and I wonder if that's because we're in 3 dimensions. I have to have 3 coordinates, right? And so I might look up at the top where I'm seeing those same, right? So I see it here and here and here. I see that same notation, the parentheses with letters or the parentheses with numbers. And I go, okay, so those are my points. That's what tells me where a point is. And then I look below that and I see that just the numbers are called elements. And I might need some help thinking back to, when did we talk about elements a lot? And we talked about elements a lot back in the first D lessons, right? The first dimensional lessons. And so we might need to help our students when we talk about elements. What are we talking about? Right? If you're in the right cycle, and I don't remember which cycle it is, right? But if you're in the right cycle of foundations, maybe you're memorizing some elements. And so this is an opportunity to connect with your students. Well, what do we mean by elements, right? They're the things we make up other things of, right? They're the things that make things up. right? So whether it's carbon and oxygen making up carbon dioxide, or hydrogen and oxygen making up water, those are elements that make something up. Or here we see that the elements 3, 2, 1 make up the thing that's below that, which is the set. Right. And so having that conversation with your students, asking them, do they remember this? Where might they have seen this before? Right? Where else do we use that word, elements? And then asking them to compare what's different between coordinates, elements, and sets. Right? Well, my coordinates have parentheses, my elements don't have anything, and my sets have braces. Right? So that notation might be helping me to know, am I talking about coordinates, elements, or sets? But even if they don't necessarily remember what all of those are, we want to ask them, right? Think about your memoria. What is this like? Where might you have seen this before, right? What's the difference between the three? How might you know which one we're talking about?
Mhm. I really like that. I like that the questions and the conversation continues, because when we approached it, we kind of approach it like a Sudoku puzzle, where you see, oh, 3, 2, 1, then you see the next one. So obviously those three numbers go into those three blanks. And we're falling back into, all right, finish filling the blank and move on. And so, and when is it okay to do that? I mean, maybe at the younger age. And how do I do that without exasperating them? Like, like trying to slowing down and say, hold on,
Well,
I want to have a 5 common topic question with you. And then they probably would say, stop 5 common topic me, mom. I don't know. I mean, when is it
well,
okay for them to just play Sudoku and plug in a number and move on? Or
yeah, I mean, you can't have a conversation about everything on every page, right? So as a parent, if you preview the lessons, so here's a couple of things I would say is if you preview the lessons as a parent, you might go, huh, this is something that I'm not sure about. I need to talk through this. I don't know if my students are going to be sure about this. So I'm going to pick this as the thing that I really want to have a conversation about. Or you might say, oh, this is something I love and I really want to share this with my students, right? So maybe you watch the video with the tissue box, so talking about the different octants, and you're like, oh, that would be really helpful. That helped me. I want to help my students. So there, I would say, based off of your interests, you could pick out a couple of things that you think this is something I want to do. Or you could see where your students, right, either something that you thought they would struggle with and they didn't, right? That would be a great place to go, hey, I thought that was hard and you didn't. So let's talk about that so you can teach me.
mm,
And that slows them down and makes them say, okay, well, I saw the pattern, but now having to talk about it and explain it is a whole different level of understanding. So that's one way to get them to slow down. Or if there's something that they don't understand and they come to you and they say, this doesn't make any sense to me, right? In the parlance of a 12-year-old, this is stupid. I don't know why this is here, right? Right? Because that's how, if they don't understand something, it must be a problem with this and not with them. And so there's an opportunity to go, well, why do you think it's here? What do you think we're supposed to practice? Where have you seen this before? What's this like? And so helping them to go from this place of, I don't get this, to walking them through, helping to model for them, what do we do when we encounter things that are unfamiliar? Instead of just putting them aside, how do we take a deep breath and engage with them? So I would say those would be maybe the 4 approaches that I would take to picking out the things. And we all know that there's going to be weeks where you're just going to get done what you need to get done. Right. So Babs and I were just talking about the fact that the Lord sent her a lot extra last week. And she said he was gracious because he picked the best week he could have picked for me to get all this extra. But we know that he does that. He sends us extra things. And so there's weeks where maybe we just go through the tops and talk about those. Maybe we don't have any conversation about anything in here. We just tell our kids to read the pages and do what they can. And then there's other weeks where we think, oh, that was the most beautiful conversation I've ever had. Why don't I do that every week? So,
Mhm. Okay, thank you. That's very helpful.
all right.
So go to keep going, go into monomials and talk about those symbols,
Oh,
the on the far right. Finish your
uh,
conversation there.
here. So yeah, so note that the next thing I would do is if we're having that conversation with our students and we've talked about comparing within their page, is that then we have this, if we have multiple ages around the table, we have this great opportunity to say to them, okay, now let's compare from integers to fractions to monomials. What's different, right? And we're not asking them to explain, we're just saying what's different, what changed. Well, the only thing that changed from integers to fractions was that we're now including this each time, right? And so maybe this would be a great place to say, okay, well, why do you think they wrote X, Y, Z each time? Is that to help us to see the connection that X is 0.3, Y is negative 1.0, Z is 0.5? Right? Is that why it's different? Hmm. Well, what's different between that and looking at monomials? Because that one now has the XYZ there, but it's got this extra notation here. And now I'm going to ask my students, well, what do those symbols mean? Right? Do you remember what those mean? Well, we might connect the elements and RE, right? They look similar. If we haven't connected that before, that might be a connection that we make here, right? So now I might say to my students, okay, well, let's look at integers and fractions. And I wrote 0.3, negative 1.0, and 5. But here I'm writing 1/8, negative 1.11, and 4 and 1/5 are elements of, oh, well, it's not the natural. So now I have to stop and think again, right? Because I'm not just copying. So 3, 2, and 1 were elements of the naturals. What are these? Well, they're all rational numbers. What's the symbol for that? It's my Q, right? And so now I'm getting them to pull and comparing to what was my example. I'm looking at what I was doing, and then I would say, okay, let's read that. So in fractions, we have the elements 3, 2, and 1. In monomials, I have the elements 3, 2, and 1 are elements of the naturals. And now I'm going to do this again, and I see that I can't just choose naturals, right? I can choose the appropriate number set and have a conversation about that. And then below that, right, we've talked about we have the braces, but we're adding something new. So maybe I write my set 3, 2, 1, because I do that in each of my domains, right? My set 3, 2, 1. And then I look at this and I go, oh, wait, right? That was that. And then we stop and we think. And maybe we try to remember, and maybe mom says, well, remember your less than, greater than, right? So if it was an angle, that would be a less than. So what being with sets is kind of like less than, right? Oh, well, a subset is something less than, it's smaller than, it's doesn't include everything. So that subset, right? And then of course, I wrote the wrong numbers here, but I would be copying down. So I would have 1/8, negative 1.1, and 4 and 1/5. So the set of is a subset of the rationals. It's not the whole set, it's a subset. So I can take that conversation and go as far as I want to with my students by comparing across to really emphasize how we're building that notation and then taking the time to read through also. And if we're doing that at the table with multiple ages, right, not only am I reviewing with my older students what element of and subset of mean, but I'm also modeling that for my younger students, right, that they're seeing that same conversation, even if it's not on their lesson page.
Yes.
All right. So on day 2, we look at our invention page. And just a reminder that that invention page is the same for all of our domains. So we're using our integers page here as our sample, but it would be the same, just a different color for fractions and monomials. And on this page, the goal is to practice the 5 common topics. And what we're building towards is helping our students to tell you everything that they know about this topic. Right. Or eventually tell a tutor everything that they know, or if they're going on and furthering their education and they go, wait a minute, what do I know about this? Right. The common topics of invention are what help them to do that. So the skill we're looking at this week is comparison. And we can look at any 2 elements on the page. So you just ask your students. You could even say, okay, I want you to close your eyes and point with both fingers. All right, now look at those 2 things, right? What is different? And then how are they different, right? So if I had, for example, turn on my highlighter. Let's say that my finger landed here and here, right? What's different between those?
One's a cube and one's a sphere.
Yep. What else is different?
Well, one's divided into their octants, the cube, but the sphere isn't, which makes me wonder if I could apply that knowledge and figure it out myself. And the reason I'm saying that is because it's exactly what Christy and I talked about, I think yesterday or the day before, when I went to her and said, what's an octant in polar coordinates?
Yeah. They all have a center point. Both have a coordinate of 0, 0, 0, 0, 0. It'll be a point.
Both have X and Z.
Which just make me go, well, what happened to the Y? So I'd want to know more about that.
So notice when we say what's different, well, the shape is different. Well, how? One is a cube and the other's a sphere, right? One's all straight lines, the other one's got a lot of curved lines, right? What's the same? Well, the letters that they use are some the same and some are different. Okay, so what letters are used, right? How are they the same? Well, they both have X's. Okay, they both have a Z, but they don't both have an R, a theta, a phi, or a Y, right? They don't both have the O's with the Roman numerals. So even if we don't know what those words are, right? Notice how I just took what you said mathematically, and if I'm a kid that doesn't know anything, right? They can sit there and they can say, well, they both have lines, they both have black lines, they both look like they have some dashed or dotted lines, but these are straight and these are curved. And then you could also look at the nuance of what is the same, right? What's exactly the same and what's similar. Right. So some things might be similar, but not quite the same, right? And so asking them, well, they both, right, have a coordinate, right? That we just talked about the coordinates, right? So they both have this coordinate notation where there's these 3, although I guess that's not necessarily written on the one, right? But I might see that, right? There's this coordinate that's similar, but what's inside of it is different. So it's the same meaning, but it's communicating it a different way. So we can take that with our youngest students, our least experienced students, and be very literal, right? Or with our older students, we can start to become more nuanced. But the goal here is not to practice the math, but to practice the skill of learning, right? It's to practice comparison. So having them look and giving them the time, right? Say, okay, well, what else? What else? What else? Right? What else? Just asking them to continue to take those 2 things. So notice we don't have to do the whole page. You can pick something out if you want to, but it's okay Right. I just remember from, again, my tutoring days in the Challenge A classroom where we had to compare, I think we were comparing a pencil and a table, right? Two things that seem so hard to compare. But as you give the students time, you come up with all kinds of things that you can say about them. And so that's the same thing that we want to do here is give them that time to really play with differences and similarities. All right. So here's our lesson pages for day 2. Are there some questions from these pages anybody would like to talk about? One thing that I would say that if you're working through these and your first year, second year, and you're not diving super deep into memorizing all of the formulas and all of the things, is just ask your students to flip through the book. And what do you notice a lot of? There's a lot of places, right, where I have 1, 2, 3 lines, right? Look here, 1, 2, 3 lines. Down here, 1, 2, 3 lines, right? 1, 2, 3. Even over here, I have 1, 2, 3. Right? You could even give them a highlighter and say, go find all the places that there's threeness, right? Because we're in the third dimension. So that's another way, right? Without actually diving into completing the exercises, there's another way to use the booklet, right? To pull out and say, what are some patterns that you see throughout the booklet?
Mhm.
I feel like we get a lot of questions about the P. And like maybe it's throwing people, but isn't it just representing a point?
Yes, it is in this case. This is a point. This is a point. Now, once we put, like in this case here, once we put a vector symbol over it, we're using it to represent a vector, but we still use P because we're saying that this vector represents a point, right? It's a vector to a point. So instead of talking about the point, we're talking about the vector that goes to that point. But yeah, that P is almost always going to be a point.
I think just using another letter, maybe that's what's throwing people. I don't know. Maybe they're seeing, oh wait, why is this P here? And just, but it's just representing something. So it's not
Mm-hmm.
that's really all it's significant for, right?
Yep.
Mhm.
On the pages we did previously, there was a place with a P and a place without, and I was going to point out, but we'd spent so much time already, that points that you can have the 3 coordinates without a letter or with a letter, depending what it is you're trying to get them to look at.
All right. I'm going to go ahead and take us to day 3, looking at our Memoria and arrangement page. And this is again, we're not looking to master the math, although there's a lot of math here that is good to put in our Memoria, and it is arranged so that we see that memory work in context. So that's important. But our goal is to practice our skills of Memoria, our core habits of Memoria. So this week we're talking about expressing. And so here's some questions you could ask your students. What could you draw or build to help you remember the content on this page? Or how could you move to remember something on this page? Or could you recreate something on this page in a different medium, right? And I put that little smiley face there for stick in the sand because when we lived in Florida, we did have our share of trips to the beach, and we would take school with us, and we would draw usually our maps. We would do a lot of our mapping by drawing our maps in the sand, right? So we'd get a stick and we'd actually literally draw in the sand to practice. So asking our students, right, to look at this page, our goal is to build our memoria. So how could we do that? By drawing, moving, right, copying, right? Another thing that you could ask that I put here is another way to write numbers. So notice here, we've got these numbers. So ask your students, right, how else could you write those numbers? Could we use tally marks? Could you use Roman numerals? So there's a way that you can pull back from lesson 2, some of those things that we did a long time ago, and ask your students to rewrite them as another way to practice that memoria at the same time as this memoria. And that takes us to our page 3 lesson pages. And so I just want to point out here that, right, as we look at this, this looks like we're doing algebra, but all we're asking the students to do, right, is 10 minus 10, 10 plus 10, 10 minus 9, and write those numbers there. So it's very much scaffolded to lead them towards where they're going to be doing that work themselves. But just getting them familiar with that notation so that it's not scary by the time they get to high school and actually start to do those algebraic computations. And this is, I'm just also going to point this section out here, that this is a really great time to start using things around you to help pull things off of the page, right? So you could ask your students, okay, right, if I had, right, now I see that I've got these 2 planes, right? I'm not going to try and hold up 3 pieces of paper. I've got these 2 planes. Do they ever intersect? No. But could they if I did it this way? Sure. Right. Well, what does that intersection look like? Right. So when we see things here, finding real world examples is something that we can do to help them visualize and connect the 2D representation to that 3D drawing. On day 4, our I page, our frame, is our careful calculations page. And another way you could use this page is use this as your on-the-go option for math. So you could use a page protector and just keep them in your car. So anytime you go anywhere and you want to have some kind of practice on the way, you could just say, okay, pull out your careful calculations. And you could even have a binder that's got the careful calculations from each week in it, and just say, okay, pick one of your pages and go through and work on it, right? Or if you have multiple students, maybe you say, okay, everybody swap and do what you can of your brothers or your sisters, right?
Mm.
So now your younger students might go, I don't know what to do. And you say, well, look at it. What could you do? Could you copy it? Could you do something with it, right? What could you do with that if it looks really unfamiliar to you? And then you can always use dice or cards to change numbers, right? So again, using this as a model, but then using some dice or cards to change numbers. That's not always a perfect way to do this, but it's one way that you could add more work into the careful calculations. Any questions on that page?
Not a question, but I was talking to a parent a couple of days ago, and she was saying over Christmas break, that's what she used careful calculations for, because they didn't do them during the school year, that when they were doing the lesson pages. And so she would just randomly pick one and say, hey, let's work on this one this week and see how many we know. And then she kind of made it like a seek and find. If they didn't know the answer, they would go look in the book together and see if they can figure it out together. So I thought that was a great idea for families, because well, in my community, we end like the first week of May. And so we're not necessarily always ready to be done with anything. Well, they are probably ready, but I still want, them to do school. And so that's what we could do. We could pull some of those things either we didn't finish from previous booklets or careful calculations, just kind of like as a review.
A great idea. And here's our day 4 math. And I'm not going to talk about the bottom yet, because that was a question that was sent in. So we have a slide where we're going to talk about that bottom section. But does anybody have any questions on the top parts? And I think one of the things I really appreciate about what Lee is doing for our students is that we are going to repeatedly see this 1D, 2D, 3D comparison. right? So that gets us back reviewing what we've done in the past, right? And it's also helping our students to see what is the pattern as we move forward, right? What's the pattern? What happens? How do we do this as we move forward? What's the same? What's different? Any questions? All right. So just a reminder of all the ways that we are here. And one more time, because I don't think we can ever say thank you enough to Lee and Classical Conversations for supporting all of the ways that we offer support to our families. All right. That unlike every other curriculum that is out there that just says, here, buy this. Here's your teacher materials. Go figure it out. Right. Lee has provided the companion, the forums, your community, email, the book club. If you're a tutor, you have access to Babs every single day. Or you can register for a math help desk. So there's so much help and support available to families. And I just really, we can never say thanks enough for supporting that and making that available. Next week, we'll be talking about lesson 20. So we'll have 3 more weeks in 3D. And then in February on the 11th, we'll pick up and look at 4D. So let's go ahead and look at a couple of the questions that have been sent in. So I just said we're going to talk about that section from page 4, and we're going to do that in conjunction with looking at this section from monomials, week 16. Because this looks, I think, it tends to look alarming, right? Because there's so much notation and there's fractions and there's radicals. There's a lot going on here. So let's stop and talk about what we're really looking at in each of these cases. I'm going to turn off my highlighter. Okay, so as we look at this, the basic idea, I'm going to do it in 2D first, is that in my rectangular coordinates, I have some point x, y, and it could be in any of my quadrants. I just happened to pick that one, right? There's my point x, y. Well, if I was to overlay on top of here, right? Also called the x-axis or the polar axis, right? And then we usually draw our circle to help us to get a sense of our polar. Right? We would have an angle, right? So this would be theta, that would be some angle, and then this would be my radius. And so we know that in our rectangular system, we could say this is xy and find it. But we could also give polar coordinates in order to find that same point. So imagine if there's a tree in your backyard and that's our origin, right? And you tell your students, okay, looking at the house is negative and looking away from the house is positive, and then to the right is positive and to the left is negative. I want you to take 4 steps to the right, and then I want you to take 7 steps away, right? So that would be my 4, 7. And my students would get to a point. And then, so let's say big brother does that. Now sister comes along and I say, okay, this is what I want you to do. I want you to turn about 30 degrees, right? So that's a little bit less than halfway from your right to here, right? So you're going to turn. And now I should have picked numbers that I could do, right? Instead of making numbers up. That's always a bad thing to do. And I'm going to tell her, let me think, 16 and 49 is 50, 64, about 8, I guess. I'm off a little bit there. And I'm going to say, okay, now I want you to take 8 steps in that direction. And she's going to bump into her brother because I just gave them 2 different ways to get to the same place. And so that's all we're doing when we talk about the difference between the rectangular and the polar coordinates. So as we look at this, what we're doing is talking about how do we do this. So we talk about it in our trig week because if I make a triangle here, right? Here's my triangle with its origin, right? With the vertex at the origin. And I'm just going to be mom for just a second. Um, um, so as we look at this, this is my y, this is my x, this is my r, this is my theta. And so now we've put all of those pieces into one triangle. Okay, so let's redraw that. Here's my right triangle with theta, y, x, and r. And as we look at this, we go, oh, right? There's two things I can use. One of these is the Pythagorean theorem, where x squared plus y squared equals r squared. And we're in lesson 16. I now might think about my trig ratios, and I really want to make my x and my y go together. So as I look at these, I'm going to say, okay, well, if the tangent of theta equals y over x, because that's my opposite leg over my adjacent leg, then theta equals my inverse tangent of y over x. Right? So now I find out that I've got this way here of relating my x, my y, my r, and my theta.
Dr. Gilpin,
Yes.
when we do this on week 16, I know that there will be questions from my kids that, Mom, what is SIN? What is COS? And what is TAN? And I can tell them to move on and just plug in the number. How do I go about having a conversation without falling into didactic teaching? You know?
Well, I would say here, I wouldn't dive into explaining it. I would say the first thing we need to do is memorize this.
Yeah, if they want an explanation, I would get the same lesson down in naturals, right? Where naturals says over and over again, what are the definitions of those three words that between them and fractions? And they're very easy definitions. So you could
Okay.
look backwards also.
Okay. Thank you. I'll look it up.
Mhm.
And
Yeah, that's
Mm.
where I would start with those students is like, hey, look, we're not going to worry about what does this mean? Let's go back and let's memorize because that's on our very first page. We've seen that SIN is sine, and
Mhm.
that means it's the ratio of the right, and just practice that memory work. Then once I've got that, I might start to say, okay, well, let's look at this. Now here with this lesson, I'm explaining this not for the student, right, but for the parents. I had this conversation with somebody this morning and I said, um, for a lot of people, right, not everybody, but for a lot of people, trigonometry was where they got to trigonometry and mathematics in high school and went, that's it, I'm out. Because it's a whole new language that you are taught on Monday, right? You're told these words on Monday, you're expected to take a test on it on Friday, and you never really have time to get that language in, and you're supposed to be solving problems and it never makes sense. And your teachers try to give you hints like SOHCAHTOA to help you remember, and right. And for a lot of people, they just go, that's it. math is too hard for me and this is awful. And so when they think back on their high school experience, they don't remember that trigonometry is this amazingly practical, helpful tool that is just about ratios. They just remember it was this whole language that they never really understood. Right. And so that's why Lee and I continue to say, go back and practice that grammar, practice that grammar, practice that grammar, practice labeling a triangle, right? So take your triangle and say, if this is theta, this is opposite, this is adjacent, this is hypotenuse, and so forth, right? That practice that, and then, right, for you as a parent that's now seeing this for, more times, that's when you start to go, okay, now I'm starting to see how these pieces are connected. But I wouldn't try to explain this to a student, right, until they're ready. So you might say, look, let's draw these on top. What do you notice? Right. So I certainly wouldn't their first year, maybe not their second year, but as they get older, I would start to say, well, look, can you see how this triangle relates these things? And then see if they can come up with this from that. But that's what we're practicing.
I'm actually helping one of my students, and this is actually in the curriculum. This girl just kept saying to me, but I don't understand what sine is. My mind can't wrap around using that word. So I said, okay, everybody get your piece of paper and write these words. And we literally wrote out the words, the length of the leg opposite to theta, put a division symbol under it, and said the length of the leg of the hypotenuse, or the length of the hypotenuse. And it said, you guys can write out those words for me every time, or you could just write SIN, which is easier. It's just a code.
That's great.
For all these big words.
That's a good one. Yeah.
And so when they saw that, then we could do the other ones, and they're like, oh, that's why you keep telling me opposite. That's why you keep telling me adjacent. That seemed obvious to me. It was not obvious to them at all what was going on.
Super helpful.
Yeah.
I just want to add quickly because my daughter thought she was finally getting it. We were on this very part here, and it has a calculator thing. So you're to figure the degrees when you're switching to polar coordinates using the calculator, and she was getting the wrong answer she was so frustrated. So I just want to point out that your calculator can be in degrees or radians. And so I feel like that's a really common error. I finally realized you're in radians and you want degrees. And it's not such a different answer that it feels like, doesn't feel obvious. It's like, anyway, so that might be helpful for people to know too if they struggle with this section, because you think you've got it down and then that's not what the book says. Anyway.
I found it helpful with my boys as we drove through town to say, I'm going to take the hypotenuse when I was going somewhere and say to them, if I went right, where would I have to go left? So not only was it map building for a community, but it was getting them used to this idea that these relationships are everywhere. You can't get away from them.
That's good. So Jenna, when do you start teaching or them to use the scientific calculator?
Well, in the monomials book, it has a calculator there. And so we just put it in, like I wasn't necessarily teaching. We just put in this tangent. We found the inverse sign.
Okay.
There's also the second button we were just kind of playing around. So I was like, oh, look, there it says tan -1. So let's put that, and then let's do 4 divided by 3, press equals, and it said 53 degrees. So it was really exploring this exact exercise.
I think they would. When would you give them as a toy to play with? Like, how old would that be? Because for the younger mamas that's out there, I think that's one of the questions that when is long division? When is so they still want to know. So I was wondering, like, when should you give them a scientific calculator and without intimidating them?
Well, I think it's okay to give them a calculator at any point, right? And let them play with it. When would I let them use it for different things, right? So if we're practicing division and I want them to understand division and know how to divide numbers, I'm not going to have them do it with a calculator. If they have demonstrated that they know how to divide, then use a calculator, right? Or use a calculator, and a transitional skill is you divide, now test your work, test your work with the calculator, see if you get the same answer. And then I can transition to, okay, we're focusing on other things. I want your brain power to be on noticing the patterns, not on the, churning through this long division. So use your calculator. But it's a transition. And it's okay to give them a calculator to play around with for arithmetic, as long as that's not what they're doing when you're trying to teach arithmetic. Now, there are some things, right? The reality is that we don't use the trig tables, right? So we could give our children trig tables and they don't need a calculator. We can emphasize, and Lee does emphasize in a lot of places, the 30, 60, 90 triangles, right? So we've memorized those 30, 60, 90s. And now I should be able to go back and forth. So if I see, the sine of theta is 1/2, I should be able to go, oh, well, that's 30 degrees, because I know that those two go together, right?
I could substitute this whole conversation of the word calculator to AI, to ChatGPT. I mean, how do you use it, right? Like, it's not that you can't use it, but what do you
Well,
need to do before you use it?
my children are both very anti-AI, so that is a whole other conversation. But
Sorry.
but yeah, responsible use. But that's it, right? We want to be able to have that. When is a tool responsible, right? So I'm sure that it was a big deal to go from hand stitching to using a sewing machine, right? To go from a pump to using a faucet, right? We have these technological things, and there is a conversation about when are those tools the appropriate tool to use. And so in this case, we see that our students, we haven't memorized, probably we haven't encouraged them to memorize, right? That the inverse tangent of 4/3 is 53 degrees, right? So that's a case where I really need to use a calculator, because that's not one that I've memorized. So there are cases where I need to use a calculator in order to calculate my answer. So back to this problem, I just wanted to come back and point out that what we're talking about when we look at these conversions is it's the same point, and we have two different ways of locating them, and we want to be able to go back and forth between the two. And we're going to use the Pythagorean theorem, and we're going to use our tangent. This radius, is just how far away from the origin is that point, right? So it's the Pythagorean theorem. It's also the distance formula, right? Because we're talking about the distance between 0, 0 and the point xy. So whether we call that the Pythagorean theorem or the distance formula, that's what we're doing when we calculate there. And then again, noticing, and we could use, right, sine or cosine if we have calculated r first, but we typically use tangent because we have been given x and y. So especially if we end up with a rounded value for our r, we want to use that exact value that we're given for x and y, and tangent lets us do that. So when we look here, right, notice this is our Pythagorean theorem. We're solving for r. And then here's our inverse tangent. And as Jana pointed out, sometimes we get that inverse tangent by using a second, depending on your calculator, it may be a function button, a second button, a shift button. It might be like a little up arrow button that get us to that sort of second function. So on a lot of calculators, I don't know if I have one handy here, but it'll have a tangent button, or then it'll have like a second function or something like that. And when I push that button, now the tangent button is the inverse tangent. And it does matter whether you're in degrees or radians, since we're given, in this case, where Lee is giving the answers in degrees, we want to make sure our calculator is set to degrees, right? Or if we get radians, right, to recognize that what we've gotten is radians. So in 2D, right, I only have two things I need to worry about. This radius, this distance from the origin to my point, and this angle to my point from my x-axis. Now, as soon as I go into 3D, so here's my x, my y, and my z, and I'm going to try and draw my sphere. I won't necessarily get it done well, right? I'm going to have still my radius. That radius is still going to give me the distance from the origin, right? So if we think about my distance formula, I now have 3 coordinates. So that's why I have 1, 2, 3 to get my radius. My theta is the same theta that it was for polar coordinates. So this is really hard to illustrate, right? But if I had, I should have a globe. I'm going to grab a globe. Give me 1 second. So here's my globe, right? My theta is still, imagine my XY plane is this way, right? Cutting through my sphere here. It's still going to give me my angle in the XY plane. So if my polar axis, my x-axis comes out here, right? My theta is still telling me how to rotate from that x-axis, right, in that horizontal plane. So it's the same as it was in my polar coordinates. It's still just using my y and my x because that's where that is. But now I need one more angle. That angle is going to be from my pole down, right? And so this one now, if we were to draw this out, we would see that I'm going to need to know my triangle is going to look, I'm going to think for a minute. So I'm going to have my point. So here's my R, here's my Z. This is my Z. And this is my angle. Making sure I've got this right to my point. Because it's cosine, which is adjacent over hypotenuse. No, it's this angle. It's not this one. There we go. I got it. So here is my, right, this is if my point was here, right, and I was to draw in my triangle, my Z coordinate, this is Z, my hypotenuse. My R is my distance out. And then this is going to be my theta, my angle down, right? My angle down. And so now my cosine, well, phi is going to be R, my adjacent over my hypotenuse. And for some reason, this is not coming out right. I may have drawn this wrong because it should be Z over R. So maybe this is I did. I'm going to erase this. So I apologize to everybody that's trying to follow this. So I'm going to redraw this so that it's drawn correctly and makes more sense to all of us. So here's my Z. Here's my Z. And off my Z would be my point. So this is my right angle. This is my radius. This is my theta. So this is my Z. So now I see that my cosine of phi, sorry, use the right one, is my adjacent Z over R. So phi is going to be my inverse cosine of z over r. I see we're losing people here. But hopefully for the person who sent this in, hopefully you see where all of this ties together. And then, so this is the same. This one is the same as 2D. This one extends to 3D. So we're locating where it would be in the 2D point, and then we're coming down from Z with that third angle.
So Andrea asked in the chat, would the theta ever be in the 90-degree angle?
No, because it's always, well, no, and I guess it could be if my point was here, right? If this was my point, this is what I would end up with, right? I wouldn't really have a triangle, so my theta would be 90 degrees, and that's where my x would be 0, so that's where I would say that my tangent is undefined, because I would have y over x and my x would be 0. So that's where our calculators don't do us any favors, but we could understand what that would look like. So I can't actually draw the triangle because it would just be this line here to be 90 degrees, and then I wouldn't have a triangle. So it will never be here, but it can be there, and the triangle would disappear.
Okay.
All right, so let's just go ahead and take a look at the last couple of questions that are in here for people who are waiting for these. The question here is just the inside or outside of the circle. And this is where it's really helpful to remember what the definition of a circle is in terms of its equation. So let me change my pen here because okay. So for a circle, it's right, x squared plus y squared equals r squared. For an ellipse, it's x squared over a squared plus y squared over b squared equals 1. Or I could rewrite that so that it equals a squared times b squared. My other ones are open, so I'm just going to look at those two. But in this case, right, if I said that this was, this is still kind of talking about my radius. This definitely is talking about my radius. So if the points are less than my radius, now it helps us to think, oh, it's going to be inside, right? What's less than my radius is inside. If it was greater than my radius, well, it's everywhere that's outside. And similarly for our ellipse, right? If it was less than my radius, right, less than 1, it's going to be inside. But if it was greater, now it's going to be outside. So hopefully that's a fairly quick but clear way to understand, right? The less land is inside because it's the less than the radius versus greater than, which should be outside.
Yeah, that was my question. Thank you. That makes a lot more sense.
Good. And then I'm going to go through this because this is another question that we've had really commonly. And so this is hopefully going to be something that people can use, Babs can use this to help people. So we've seen, especially in lesson 16 and on, one of the questions has been about students are getting this answer, but the answer key says this. And there's a lot of questions about why that is. And so I just wanted to step through how we rationalize and realize the denominator. And historically, mathematicians just really said we want to have rational denominators, which really works out to being natural numbers in the denominator. And so what we can do is when we have a denominator that's not rational or not real, we change it so that it is. So in the case of a single radical, so something like 1 over, and I'm going to say here, I'm going to say the cube root of 4. is I want to show you another, a slightly bigger example. Well, if I want the cube root of 4, I want to be able to make that a rational number or a natural number. I need to have, how many 4s do I need to have in order, right? I'd have to have 3 4s. So I can multiply this by the cube root, as long as I still have to keep the cube root, but I could say the cube root of 4 squared, because that becomes the cube root of 4 times 4 squared, which is the cube root of 4 cubed, which is 4. So I'm picking a more complicated case just because I want to point out that when it's a single radical, we can do this no matter what index we have. Most commonly, we do it with the square root, so I'll show you that, but I wanted to give you an example where it's not. So because, right, I want to multiply by 1, if I'm multiplying my denominator by the cube root of 4 squared, I'm going to multiply my numerator by the cube root of 4 squared. So this becomes
I'm
the
glad you
cube
did
root.
that because I was like, wait a minute, what about the what about the numerator?
So yeah, so that becomes the cube root of 4 squared, the cube root of 4 squared, which is the cube root of 16. That, that does happen to simplify, but we're not going to worry about that for right now, because I just want you to see the process here. That what we did was we took our radical and we transformed it into an expression that had no radical, and we ended up with a radical in my numerator. So let's look at 1 over the square root of 3, right? So if this is a square root, I have 1 3 already. I need another 3. So again, square root, I need 1 more 3. So this becomes the square root of 3 squared, which is 3. What I do to the denominator, I do to the numerator. So I'm going to multiply my numerator by the square root of 3 also. So 1 times the square root of 3 is just the square root of 3. And we see that the square root of 3 over 3 is the same as 1 divided by the square root of 3. So that's the case of a single radical. Now, the other thing that we can rationalize is a binomial that has square roots. So notice here I'm very specific that it's square roots and not cube roots or fourth roots. So this is the case. Let's say I had 1 over 1 plus the square root of 2. If I wanted to rationalize this denominator, I can use the conjugate 1 minus the square root of 2. Again, doing the same to the numerator and the denominator. When I multiply 1 plus the square root of 2 times 1 minus the square root of 2, I end up with 1 times 1, which is 1. 1 times negative 2, which is or negative square root of 2, which is negative square root of 2. 1 times the positive square root of 2 plus the square root of 2 times the negative square root of 2, which is going to be negative square root of 2 squared. My numerator just becomes 1 minus the square root of 2. So notice negative square root of 2 and square root of 2 are 0. The square root of 2 squared is 2. And so my denominator becomes 1 minus 2. And so my rationalized fraction becomes 1 minus the square root of 2 over negative 1, or negative 1 plus the square root of 2. Those are not intuitively obvious, right? I don't think. I think you can, with this case here, I think you can sort of over time become familiar and see a little bit more intuitively what's going on. I don't think that the second case is intuitively obvious. I have to work it through every single time. The third case is when we would realize a denominator. So let's look at the case where I have 4 divided by I. There's 2 approaches. Lee likes to take the approach of I need a 1 in the denominator in this case. So I would multiply by I cubed, because that would give me the fourth power of I, which is 1. So then here I have 4 times I cubed, and I need to simplify that to -1, and I end up with -4. I tend to think I only need to multiply by I over I, so that I end up with 4I in my numerator and -1 in my denominator, and I get -4. So either way, it gets the same answer. If I had, let's say I had 4 over 3I, I only need to worry about the I part, right? I only need to worry about the imaginary part. So I would still end up with 4I only over -3 this time. And then I would generally move this to make it -4/3 I, but those are all equivalent notations. So that's realizing if you just have an imaginary number. And then if we have a complex number with non-zero parts, something like 4 over 1 plus 2I, I'm again going to use my conjugate, 1 minus 2I. And again, I'm going to see that I have 1 plus 2I minus 2I, and then minus 2I squared. And in my numerator, I would have 4 times 1 minus 2I. So in my numerator, I'm going to have 4 minus 8I. In my denominator, I have 1. These are 0. 2I squared becomes -4. My negatives, they're going to cancel out. So I would end up with 5. So I would end up with 4 minus 8I over 5, or 4/5 minus 8/5 times I. So for where we are, this is what most people need, right? For what we're doing, this is where most of our questions fall. But I just wanted to point out the 4 different cases of rationalizing and realizing the denominators for those who have been struggling with that or needed a resource.
Yeah, that seems to be a questions we get a lot about that. So that was good.
I think I had asked the number 1 example last week. And so I talked to my children who have taken college algebra, and I was like, please explain to me, is this ever used in math for you guys? And they're like, every time that there was something in the denominator, we had to do this. I'm like, okay, so it's not an unheard of concept. And my son was like, no, mom. Eleanor needs to start doing it immediately because she's going to have to do it eventually.
Yeah, it really is mathematically our preference. In our modern world, there's a lot of people now who will write 1 over the square root of 3, and it won't bother them. They'll use it, and that's okay. But really, if we were being elegant, we would always rationalize or realize our denominators. So that's what we're pushing our students towards doing. But it is an extra step that, we kind of need to step through and help them understand. So, all right.
Thank you for
Any
that
other questions?
explanation.
Oh, you're welcome.
It looks like somebody joined Abby. I don't know if she had questions because I saw that she joined. She was a
Hi,
newbie.
Abby. Do you have any questions you'd like us to go over? All right. Well, if not, I will say goodbye, and I will look forward to seeing you all next week when we talk about lesson 20 and solid shapes.
Thank you.
Have a good afternoon.
You too.